We're going to primarily emphasize today's demonstration on some of the features that the desktop software can do, as far as the ability to take the data that you've received back from your soil testing lab, or any other type data that you have that you want to use as a basis for creating prescription maps. It could be something, like I mentioned, the soil lab data, or it could even be, a yield map from previous years that you want to use as kind of a basis as far as how you want to create a prescription map for a planting map or something along those lines. A couple of housekeeping things, or things that we need to keep in mind as we're working with the desktop software and specifically with creating formula-based prescription maps. The first one of those is the data that's brought in. Kind of goes back to reinforce one of the items that we talked about in the previous session, is the data itself. So if we go to this layer over here on the left-hand side in our management tree, which is our 2017 soil test result point data, if I right-click on that and go to layer properties, the key factor that we're going to use here is in this type column. You'll notice that there are very specific attribute types listed there. As we're setting up the formulas that we're going to set up are going to be general formulas for the program, and then those formulas can then be applied to any layer that would have that specific attribute in it. So in this case, as you see there, that the type column is set up as those specific attribute types. And as we imported that data in the last demonstration, we walked through how to set all of those up so that would work. If you have a layer that does not have those specific attribute types and you would like to work with that, then you're most certainly give us a call in the support room, and we can help you how to get those layers modified so that you can use them as a formula-based type prescription. So that's one of the housekeeping things that we're going to work with here. And the other thing that we'll need to look at and make sure that we have set up before we can really apply the formulas to the fields is we're going to need to have the different supplies set up that we're going to be working with. So here on the left-hand side, under our Inputs tab, you'll see we've got the supplies, and then under Fertilizer, we've got the fertilizers we're going to be using in today's demonstration at least. We've got a DAP, a MAP fertilizer, and then also some ag lime set up as well. Those will allow the program to know what products are going to be applied when we're creating the prescription maps themselves. So as we get started with the process, the first process that we need to do is we need to take our point data and convert that into data that covers the entire field. So right now we just have our representative soil sample locations. And we need to convert that into something that's going to more evenly cover the entire field. The program has several powerful tools built into it as far as how to take that data and fill those blanks basically between those data points, so that the program can then determine how fast or how slow those gradual changes between those sample points can need to ramp up or ramp down, whatever the case might be in that case. So we're going to go down here and we're going to work with our plain soil pH. And you notice as I changed my views from my buffer pH to my soil pH, that the colors on the map changed, as well as our legend updated as well. So that's another feature of the program that's automatically going to happen for us. So I'm going to go ahead and hit the Add View button here. And as we're working with formula-based prescription, it's very imperative that we have a gridded view of the data to work off of. Once we've created a view here, I'll create a gridded view, I'll create a contoured view. I'll show you the difference between the two and show you why it's important that we use the gridded view option here. So we're going to use, again, the first time through here, we're going to go ahead and choose the gridded view. Under the cell size is going to basically be how big of the individual grids that the program is going to create here on our screen to base our prescription map off of. I want to go ahead, I'm going to use a 70-foot grid on this field itself. We're going to use the method of inverse distance. Basically, since we've got data that are far apart, we want the program to help us determine and determine the values of those individual grids that'll fall in between the data points. Our search radius and neighbors, Our search radius, basically what I've done is I've kind of estimated the distance diagonally between a couple of these data points, and that's what I'm going to use for my search radius. Again, helps the program get a better representative sample of how fast and how drastic it needs to make the changes in those values. I'm going to use the option for fill blanks. That'll help us make sure we fill all of the areas clear to the edge of the field. The smoothing slider bar, since we're using a gridded view, is not going to come into play here. Once I click OK, the program's going to go ahead and calculate through, and now we've got a gridded view that covers the entire screen. If I click on the map, you'll see that we have individual grids here, and that's what that gridded view will do for us. It's going to create those 70-foot grids so that we can determine those values as we kind of go along here. So there's our gridded view. If I select an area on the map, let's go ahead and we'll just select that area there, and we'll go down here to our information tab. You'll notice that each of our different attributes have all got values for that one specific location on the field. That specific location, that data will allow us to use any of the attributes that we have in that view or in this layer as part of our prescription itself. If I go back to our base data on our soil pH and I create another view and create a contour view, a little easier map to look at maybe, but if I select an area on the map, it's going to be a larger area, and if I go to the information tab, the only value that area has is just the pH, because when you create a contour map, you can't create a multiple contours off of multiple variables. It can only be just that one variable. So that's the reason it's very important that we use the gridded view as we're creating our formula-based prescription maps. So that's kind of the basis of getting started. So if we're working off of a point data type map, there's our way to get it to a gridded map, so that we can gridded or an area type map, so that we can so that we can use it as a basis for those formulas. Another option, if you're working off of management zones and you've imported that data to your different management zones, you may end up with a map similar to this, where we've got different management zones. If I click on an area here and I go to our information tab, you will see that I have all of the attributes are all for each of those different management zones. There's another option for those of you who may be using management zones as a basis for your soil testing. You can use that as data as well. We're going to go ahead and switch back to our point data here and bring our gridded view back up. One thing that the program will do is, once we've created this gridded view, it will create that same gridded view in the same areas, same exact areas on the field for all of the different attributes, which allows us, again, to use those in the formula-based prescription then. So the next part of the process is actually setting up formulas. And probably one of the biggest questions that we get in the support staff is where do I get a formula to put into the program? Because of the variability in soils across the U.S., what may work here in Indiana, when you look at the soils here and you compare those to the soils maybe in the Southwest or in the Southeast, soils differ so much. There's not any one standard place that you can go to get a map or a formula that will work for every area of the country. So we're going to go through the process of entering in some maps, or entering in some formulas, with no guarantees on how those will work with the soils in your area. Probably the best source of information that you will have for your area is one, either your local extension service, or two, your supplier your supplier that you buy your products from. So they should be able to maybe help you come up with some information there as far as some formulas to enter in. Once you've got those formulas, if you need help entering them in, definitely that's what we're here and available in support for, is to help you create those prescriptions, or get those prescriptions converted into a form that you can use then in the software. We're going to go through 3 or 4 different examples here on different types of formulas, on everything from a real simple formula all the way up to a little bit more complex formula, and how to put those in, and then how would we apply those to the different fields. So to set up a formula, we're going to start underneath our resources menu and go to the bottom item, which is formulas. See, at this point, there's no formulas even set up within this program. So we're going to start with the Add button. It's going to allow us to add a formula, and we can use whatever name you would like, whatever name makes the most sense to you. I'm just going to call this one a basic potash recommendation. The formula variables is where we're going to be able to tell the program what variables or what attributes we want to use from our soil testing, our base map, whatever that's going to be. So we're going to find potassium in our list here. So we're going to use our potassium value. And I'm just going to simply label it as K. And the variable name that we're going to use here is what we're going to actually use in the bottom box here in the actual formula itself. So for the formula we're going to enter in here for this real basic formula, a real simple formula, is basically we're going to say that we've got a goal of 320 for our K value. We're going to have a look at the soil test results. We're going to have it take the soil test result value for K, subtract that from 320, and then divide it by 0.6 for our potash fertilizer that we're going to be applying. So to enter that in, we're just going to use some fairly standard math symbols. This is where that high school algebra is going to come back into play here. So for those math teachers those teachers that said, or those folks say you'll never use this math, here's the situation where we're going to use some of it. So we're going to take, again, our 320, which is our goal. We're going to subtract the current potash or potassium level, I guess. And then once we get that value, we're going to divide by 0.6 to come up with actual pounds of potash that needs to be applied. You'll notice that the formula variable that we've used is very case sensitive. And it's also space sensitive, character sensitive. So that's the reason I always recommend that when we set up these formulas, we keep those variable names short. We keep them pretty concise, either one or maybe two letters, or something that's very, very short and very, very simple to understand. So this is our first formula. Again, a very simple formula to set up and put into the program. So I'm going to go ahead and click OK on that formula. Now that formula is added into our master formula list for the program. One of the good things about the formulas as we set those up, if you would happen to be working with multiple projects within the desktop software, these formulas will be universal across all projects. So they'll be available in all of the different projects that you have. So after we've set up this first formula, we're going to go ahead and go to our information tab here, and actually I need to set up a potash fertilizer as well, so I'll do that real quick. I'm going to right click on the fertilizer, choose new supply, enter in potash, add it underneath the fertilizer and lime a financial account, and we'll say we're going to purchase that by the ton and distribute by the pound. Program will automatically set up our conversion there. We could come in and fill in some of the other information later on if we would like, but for now that's going to get us enough information for what we need to do here today. So I double clicked on that potash supply, put it into the working group, and I'm going to come in, and so we're actually working off of our potassium map. We'll right click on that gridded view that we've created and choose the option for create formula application. Once we've done that, from our drop-down list and the list of available formulas, we'll have that potash recommendation. The program will give you a brief view of that, and I'll ask, as far as the information here at the bottom, it's going to ask, if we want to set up any, or how we want to set up the parameters as far as it's setting up the map there. So at this point, it's asking how do we want to round that, and we're going to tell the program we'll just round it to the nearest 10 pounds. Or we could set that to 25 pounds, whatever the actual applicator is going to be using, however fine control that applicator has. We can set up a minimum and maximum rate as well, so that if we get to a certain point, it's going to override and apply a maximum rate if that's something that you would like. If not, all we need to do is click OK. It'll bring up a farming box for us. A farming box is in this peach color, letting us know that this is a planned job. It's not one that's been completed yet. It's going to take the name of the field and the job type, combine those together as a job name. I'm going to go in here and I'm going to add just a little bit more here. I'm going to add potash in as as a term there as part of that name as well. And nothing else on this screen will need to be changed. It's already set to the 2018 corn crop enterprise, and we'll click OK. And at that point, it's already taken our map, it's taken our potassium, our K values, and converted those into pounds of potash that needs to be applied across the field there. Converted our map, everything there. As far as this is done, we just need to hit our save and close. If we did need to want to make a small change, or if we had a small area, maybe we had one area out here in the middle of this yellow that was a different rate, and we wanted to go ahead and change it so it matched, we could change that if we needed to by clicking on that grid and then clicking on whatever color we wanted to apply to that gridded area. We'll save and done. And now when we go to our jobs tab, here at the bottom of our list is our Ocean East potash job that we've just created. So just that easily, we created a prescription map based off of that K value that came back from the soil testing lab. Go ahead and switch back to our base view here. Another type of formula that we can enter in is maybe a simple if-then formula. So I'm talking there is you could say maybe if we look at our pH values. So if we want to look at our pH values on this field, and we're going to say in the range of anything lower than the pH of 5, we're going to apply 3 tons of lime. And we've got a different chart there. Maybe we've got that we want to use as our basis for that formula. We can set that type of formula up as well. So if we go back into our formula setup, so again, I went to resources and then formulas. I'm going to add a formula here, and I'm going to call this one lime based on pH. And our variable that we're going to include this time is going to be our soil pH. So again, I'm just going to type the letter S. That'll jump it down to the S's in our list. And I need to go down here and find our soil pH attribute. And I'm going to call this one lowercase p, capital H as our variable name. So it's going to be important as we're typing in our formula that we use that pH as a lowercase p, capital H as we're typing in that formula. So again, our formula, we're going to say the first line item on our formula is going to be anytime that the pH is less than 5, we want it to apply 3 tons. So we're going to do pH less than or equal to 5. Let's go ahead and enter it in as 5.0. And then we're going to use the question mark for our then part of the statement. Then we're just going to put in there how much we want it to apply. So we'll say we want it to apply 3 tons. When you use a colon at the end of that line, by using the colon at the end of the line, it'll tell the program if that statement is false, then it should go to the next line in our formula. So we'll do our next line. We're going to do pH is less than 5.5. We better get the pH less than or equal to 5.5. Then we want to apply 2.5 tons. And we'll do a colon at the end of that line as well. We'll do pH less than or equal to 5.9. Then our application rate is going to be 2.0 tons. We'll go pH on the next line. pH is less than 6.2. Less than or equal to 6.2. Then our application rate is going to be 1.5 tons. And our pH less than or equal to 6.5. Our application rate is 1 ton. And we'll go pH less than or equal to 6.7. Then our application rate is a half ton, 0.5, and then we'll put a colon. And then if our last line item that we have there is false, so if the pH is higher than 6.7, we're going to put a 0 on the bottom line, telling it that the program should apply 0 product in any areas where the pH is higher than 6.7. I'm going to go ahead and click OK to save that formula. If we had made a mistake there, I'm going to go back and I want to edit this. Say we had forgotten to put the colon in on this line here. Once we click OK, the program will give us will do some troubleshooting for us and let us know that we have an error, it'll even give us what line number that error is on, so we can go through and then we can help troubleshoot that error that we may have missed as we were entering in that formula. So we put that colon back in there, we click OK, and now the program allows that to be saved. I guess there was a question that popped in here I just happened to catch real quick. As the question mark that is in between the pH value and the rate is just our indicator that the program uses as far as a then. So the first part is the if part, then the question mark is that then, and then it's telling it what it should do as far as that application rate, that it falls into that range. So that's what that if then is. Another type of formula that we can enter in, actually I'm going to go ahead and apply this formula to our map. So we're going to switch from our supplies to our ag lime. If I just double clicked on the potash to remove it from the working group, double clicked on the ag lime to put it into the working group, and then we're going to go to our soil pH value here. We'll right click, create formula application. We're going to choose that line based on pH, and since we are switching over to a product that's applied by the ton instead of by the pound, I'm going to change this rounding to 0.5. If we don't change that, the program will try to either round it to 0 or 10 tons as our application rate, and it's kind of a common one that we run across as we're helping folks troubleshoot their maps. So we went ahead and changed that rounding to 0.5, and we're going to go ahead and put in a maximum here of basically 3 tons, because that's what we've already told the program that it shouldn't do anything more than 3 tons. And we'll go ahead and OK there. Again, I'm going to edit the job here just to help us keep things straight a little bit. So we'll call this lime. I'm going to call it line 1 because we're going to go ahead and do another lime map here in another minute with a different type of formula. And we'll click OK on that job. So now we've got our application map showing our rates, our purple areas, our light purple areas there where we apply no product, all the way up to the dark purple areas where we'll be applying 3 tons with the monitor. So we'll go ahead and hit save and close. Again, that job shows up in our jobs listing there. So that's example 2 on a type of formula. Basically, if the range of our value from our map falls in this area, then this is the product we want to apply. The next formula we're going to get into is kind of similar to the one we just did, except for this time we're going to look at one attribute, and then we're going to use another attribute in the mathematical calculation that the program is going to use to come up with an application rate. So we're going to go back again. I guess we'll show you a different way to get to the same place that we've done before. So if we go to our pH, or actually in this case we're going to go to our CEC, because our CECs are going to be our determining factor. If we right click on that grid and do the create formula application from the start, we do have a new option here in our list of formulas that's going to bring up that same edit formula box that we had before. So this is another way to get to kind of the same results, same ends, I guess, at this point. So this one here, we're just going to call this lime rec, and we're going to call it CEC. So we're going to call it the lime rec based on CEC, and this time we're going to have 2 different attributes, and the first one of those is going to be the CEC. So we'll find it in our list here. And we could use just a C as the variable name, or CEC is short enough that we shouldn't have any issues putting that into the formula. And then we're going to use our soil pH as well. So we're going to look at our S's here and find soil pH. And then for our formula, this is where it's going to get a little bit longer this time. Basically, we're going to look at our CEC value to start with, and based off of that CEC value, then we're going to tell the program a formula that we want to have entered in here. So again, this is just another example formula that we've got just to kind of show you how the formulas would get entered into the system here. So we're going to start out with CEC greater than or equal to 36. So again, it's going to look at the CEC value for that area of the map, or that individual 70-foot grid that we've made, and it's going to look for any areas where the CEC is greater than 36, and then we've got that question mark for then our formula that we're going to put in. We'll start out with a parentheses here to help with the math. We're going to go 25.80 minus the quantity of 4.00 times the pH for that area of the field. And then we put two parentheses at the end to help to finish off the math. So the first thing it's going to do is going to take our pH value times 4, and I missed a symbol in there. We're going to do that, take whatever our pH times 4 is and subtract it from 25.8 to come up with the tonnage of lime that we get applied in those areas. I'll put that colon at the end of the line so that it knows to go to the next line if that line item is false. Our next formula is going to be for those areas where the CEC is less than or greater than or equal to 24. Then our application rate in those areas is going to be 42.35 minus the quantity of 6.67 times our pH. Again, we're just using the star symbol there for the multiplication factor. So the first part of that, the first math that we'll do there, in those areas where the CEC is basically between 24 and 36, it's going to take the pH times 6.67, subtract that from 42.35 to come up with the application rate for that area of the field. I'll go ahead and enter the rest of the formula in here. So we've got CEC is greater than or equal to 16, so it's going to be between 16 and 24. And we're going to do 36.22 minus the 5.68 times our pH. I'm going to do CEC greater than or equal to 8. Then I'm going to go 24.81 minus 3.84 times the pH. And then any areas where the CEC is less than 8, then our formula is simply going to be 13.4 minus 2.00 times our pH. And we'll click OK on that formula. Whoops, we're missing a parentheses on the end of that. So again, the program helps us troubleshoot as we're typing that formula in to make sure that we have all of the operators within that set up correctly. Again, our rounding will leave it a half ton, and we'll click OK. Brings up our farming box again for our planned job. Call this one Lime 2. And we'll click OK and see there's our map on applying lime to that field based off of the CEC value. So there's another example on another way of entering a different type of formula to create those prescription maps. Now that we've got some jobs created, we've got these 3 jobs here at the very bottom, or the 3 jobs that we've just created. The next step in that process is taking those planned jobs that we have and either sending them out through the wireless data transfer directly to a Trimble monitor for those folks who have the Farmer Pro with the vehicle connections set up, as well as the FMX or the TMX 2050 display with a modem in the tractor. We can send those directly to those machines. When we do a right click on the job, we've got an option there for work order. If we had those machines set up, my account does not have any of those machines set up, but below the mobile here would be all of the individual different machines that are set up with that wireless data transfer automatically set up for those. So once you've clicked on that, at that point, that job goes directly to that monitor. It gets sent out over the web, over the cell signal, directly into that tractor, right into the monitor, and it's there ready to be used. For those folks who don't have that or are going to a different type of monitor other than a Trimble monitor, we do have the ability just to mark that job as a console job that we want to send it out to a console. We can do multiple jobs at one time. If we right click, go to work order and choose console, you'll notice over here on the right hand side it's marked those jobs with the data card on them, showing that those jobs are ear tagged, or the ones that are ready to be sent to a monitor. And then we finish off the process by using the right job data and then choosing whatever type of monitor we want to send those to, whether that be a case monitor, an ag leader monitor, a John Deere monitor, a Trimble monitor, whatever data card we want to send those to, so that we can then take that data card, carry it to the tractor, plug it in, or the sprayer, plug it in, and then have those maps loaded in there. So if we choose the Trimble and say FMX, for example, it's going to browse and select just my USB drive and click OK. And the program's going through exporting each of those prescription maps at this point. You'll notice that the prescription maps are the ear tags on each of those jobs has gone away. And if we look at our data card, we would notice that there's an Ag GPS folder on that data card that you can then take to the monitor and plug in and be ready to use. It's going to send the client, the farm, the field information, as well as the actual prescription map itself.